Today we're going to look at a brief review of atomic structure and electron dot structures. So when you look at the periodic table, the atomic number, which is the big whole number, tells you how many protons and electrons an atom of that element have. So for example, lithium has an atomic number of 3, which means it has 3 protons and 3 electrons in a neutral atom. Electrons in the outermost orbital are called valence electrons. These are the electrons involved in bonding. All other electrons are called core electrons, and to determine the number of valence electrons, you have to use the periodic table. For example, if we look at sulfur, here's sulfur right here, and to figure out how many valence electrons sulfur has, we come all the way over to the left, and in the third orbital, you can count down 1, 2, 3, third energy level, it has 1, 2, 3, 4, 5, 6 valence electrons. And actually, anything in the same group as sulfur will also have 6 valence electrons. So oxygen also has 6 valence electrons. Now, to represent those valence electrons, we want to draw an electron dot structure. And to do that, you use the symbol for the element, so sulfur is S, and then we're going to draw 6 dots around the S. And to do that, you pick a side, it doesn't matter. Think of there being a box around the sulfur. So I usually start on the left, and we would draw 1, 2, 3, 4, 5, 6 valence electrons. So what that tells us is sulfur has 2 electrons that want to be paired up, and that's how it bonds with things. And it also has 2 pairs of lone pairs, which are electrons that are already paired up. Now, when things bond with each other, they follow the octet rule, which means they want to end up with 8 valence electrons. And they can do that 2 ways. They can either gain or lose electrons to become ions, and then ions with opposite charges attract each other to form an ionic bond. Or 2 atoms can share electrons to form a covalent bond. Now, metals and nonmetals generally bond ionically, meaning they become ions. Nonmetals tend to share their electrons and bond covalently. For example, let's look at sodium bonding with chlorine. So sodium, if we look at the periodic table, it has 1 valence electron. And then chlorine, when we look at the periodic table, has 7. 1, 2, 3, 4, 5, 6, 7. So that means sodium wants to lose the one that it has and fill up its previous energy level. Chlorine wants to gain 1. So what happens is that electron from sodium comes over here to chlorine, and what we end up with is sodium with a +1 charge and chlorine with a -1 charge and 8 valence electrons. And then the +1 and -1 end up attracting each other, and they form an ionic bond. Now, when we bond carbon with hydrogen, they're both nonmetals, so they're not going to become ions. And if we look at carbon, it has 1, 2, 3, 4 valence electrons, and hydrogen has 1 valence electron. So what happens is carbon is actually going to bond with 4 hydrogens. And hydrogen is kind of special. It really only wants 2 electrons to be like helium. It doesn't want 8, but it is becoming like a noble gas. It wants to be like helium. So what's going to happen is carbon wants to pair up all of its lone electrons, so it's going to share with all 4 of the hydrogens. And what we're going to end up with looks like this. So that carbon and that hydrogen will share. Carbon and hydrogen will share, until we end up with 4 covalent bonds where those electrons are being shared.